Here is the Allen Bradley connected components workbench. I'm just going to show you kind of how these local variables work. You'll notice in the last few videos we were in Delta and we saw some function blocks like timers and counters and things, and we used what we call data registers. There were basically we put a D0, D1, D2 value in where a number should be, and then we were able to use the move function to assign a number to it, and then we even got into some math functions. Well, that was Delta, and they just call those data registers. They're just programmed in variables, D0, D1, D2. Well, here in Allen Bradley, they do it a little bit differently. They don't really have D0, D1, D2. They don't really have data registers. We use what's called local variables. So I'm going to kind of just give you an idea of what a local variable is, and then we'll quickly go through this because, it largely is the same. It just works a little bit differently, so it's worth showing. Let us go to our local variables. This window, you notice all these variables. These are variables. I mean, some of them are like when I choose an on-delay timer, it just kind of comes up as a local variable. But some variables are variables that I made, like this CNTVAL1, that's count value 1. I just made it, I named it, and it's a digital integer. You'll notice that, all of these variables, there's a data type. And there are a ton of different types of variables. You can make almost as many variables as you want to in these local variables. But what you have to do when you make a local variable is you have to assign a data type. For example, time value 50 is a time variable. But you'll notice in the window, there's all kinds of different types of variables. Unless you're an engineer or a math whiz, you may not understand a lot of these, but just so that you know, there are variables. And what we're going to be looking at in these examples are basically these local variables and how we move numbers into them and do math functions, okay? So, without further ado, I'm just going to kind of go over the main gist of this, and then we'll get into the examples. Right here, if you can zoom in, that's an on-delay timer, and you'll probably remember in the timers and counters videos for Allen Bradley, we'd have a timer, and then we would have a preset time. That's the time that you set, 10 seconds, 100 seconds, whatever, And then we have our elapsed time when our timer, when we push the input for our timer to start, the elapsed time starts, and it kind of shows you where it's at. So our timers have a preset time and an elapsed time. The difference you'll notice here is there's not really a time here. I just put a TMVAL1. That's one of those local variables I just showed you. That's not really a time value. We're going to end up using our move functions to assign that, and I'll show you that later. But I just wanted to show you this is a on-delay timer. This is where we would put our time right here, this preset time. This is our elapsed time, and I'm even going to show you something with the elapsed time with a variable with that. And of course, here's our off-delay timer. It's not much different than our on-delay timer. The on-delay timer, you just have an impulse, and then it starts a time, and it turns something on after the time is released. Well, the off-delay, you have an impulse, and then you take the impulse away. Like, for example, if something's passing in front of a photosensor, the photosensor sends an impulse when that thing's in front of it, and then it doesn't send the impulse when whatever's in front of it leaves, and then it starts a countdown, basically to turn off whatever you had just turned on, right? Once again, this off-delay timer, I didn't put a time in there. I just put a variable in there, and there's the move functions where we will assign time values. And of course, then we're going to talk about a counter and move functions to assign count values. Then we're going to have an on-delay timer, and we're going to show how we can use our elapsed time with a variable to, set some comparators and have outputs based on what we set for the comparator. And then lastly, we will have some math functions. So I'm going to load this, and then I'll be back with you, and we will go over the examples of how these things work. Okay, so we loaded it up. This is basically our Allen Bradley simulator. You'll notice here this looks like a PLC. Why? Because it's a PLC simulator, right? It looks like the PLC. You'll notice the input that these are the inputs up here. Input 0 through input 27. These would be on the physical PLC. This would be where the wires, the input wires are wired to, and then of course. Then we have the outputs down here. You can see actually output 2 and 4 are on. You can see them by the light, but that's what they look like when outputs turn on. And of course, when outputs, and inputs turn on, we just click on them, and that basically just simulates a signal going to it, okay? Now I'm going to turn these outputs off so that they're not confusing for you real quickly. The reason why these are on is because I have counters with variables, and when I load this thing up before I do the move function, there's nothing assigned to the variable, so they start at 0. So these two counters are looking for a count of 0. Well, they've got a count of 0 because nothing has been counted, so that's why they just kind of start on. But I'm going to turn them off because I'm going to be showing you things turning on or off, and I don't really want that to distract you. So let's see what outputs we have. As you can see, I've got a lot of different things going on here, so I just need to figure out how to move a value over. Okay, so input 9 and input 16 is what I'll use. So see, these are on, the values are set at 0. Well, I'm just going to basically move a value and tell me, you'll notice when I'm turned off. Okay, so now we have a clean slate. All our outputs are off, all our inputs are off. I just wanted you to kind of see how that happens, because one of the things to know about these variables is if you have a counter, or really any of the variables, timers or anything, if you have a variable that's looking for a number and you haven't moved a number into there yet, it's going to start at 0. So that's why I wanted you to kind of see that, okay? So hopefully that made sense. If not, ignore it, and we'll just kind of go from there, okay? So here's our simulator, and here's our program. As you can see, time value 1, which we talked about before on this on-delay timer, we have an input 0 that's right here. We'll hit our input 0 and it starts the on-delay timer, and here's our output 0, which you'll see by a light down here. But right now we have 0 seconds. So if I do input 0, all it does is turns on output 0, and then I turn, it just doesn't really do anything. It's not really a timer because 0 seconds, right? So we have a local variable here, time value 1, but we need to set something. So we can set it with input 1 sets it at 2 seconds, input 2 sets it at 4 seconds, input 3 sets it at 6 seconds. Let's just go for input 3. Look here, T #0S. Oh, another thing, when we're talking about time variables in Allen Bradley CCW, we don't just put a number in there. Like with the delta, 2 seconds would be a value of 20 because it was in tenths of a second. Well, here 2 seconds is T #2S. That just designates that it's 2 seconds. So, like I say, we'll do input 3, and we have T #6 seconds. And if I move this, you'll see, so basically input 3 will move, it assigns 6 seconds to time value 1, and up here is where time value 1 is. So when I push input 3, you'll notice that 0 will turn to 6. 0 just turned to 6. Hopefully you can zoom in and see it. Sometimes the red's hard to see on these computers because it is in red, so if you can't see it, you'll just have to trust me, it does say 6 seconds. And if I press 2, I have 4 seconds. If I press 1, I have 2 seconds, right? And just like the move function on Delta, if I were to have them all stuck on 1, 2, and 3, it stays at 6 seconds, right? I can turn off 2, 1, it still stays at 6 seconds. I turn off 3. I mean, the bottom line is, we don't want these on toggle switches because then something will be left on, and if more than one of these move inputs are on, it just goes with the highest value. So sometimes people will try to turn something on and they will wonder why isn't it moving well, because you have a higher value that's still on. So I put these with momentary push buttons. All it takes is a momentary impulse of one of these to move the value over, and then when you don't have the impulse anymore, that value stays until the next impulse, and then it just changes with every impulse. So just like the delta, that's just like the delta. So right here, we have 6 seconds. Let's just change it to 4. So I push input 2 and it changed to 4. So let's make this thing work. I'll push input 0 and you'll notice the elapsed time will go up to 4, and then it'll give an output here. And then there's your output right there, your output 0, 0. And if you can see the red, you can also see the line go to your output there, but your output turned on. So we'll turn this off. Output turns off. We're at 4 seconds. Let's just go for 2 seconds. So we just changed the value. I just pressed 1. I changed the value to 2 seconds. So now when we press 0, 0, it's going to take 2 seconds for this output 0 to turn on. So I'm going to push input 0, and then we're counting down to 2 seconds, and you see output just turned on after 2 seconds. So like I say, that's how you use the move function with a local variable and a non-delay timer, right? Now let's go to the off delay timer. Pretty much the same thing, right? We just have a second variable called time value 2. This is an off delay timer. So we'll send an impulse, and then when we take the impulse away, the off delay time will start, and the output will be on until the off delay time is reached, and then it'll turn it off, right? It's off delay. So, and we have the 2, 4, and 6 seconds. We have the moves. They're just different inputs. They're 5, 6, and 7. Input 5 will move 2 seconds into time value 2. Input 6 will move 4 seconds into time value 2. Input 7 will move 6 seconds into time value 2. So it's pretty much just like the last timers. It's just an off delay versus an on delay, right? So let's see here. Right now, our value is 0. I will push input 6. Our value is now 4. I will push input 5. Our value is now 2. Hopefully you can see that. I push input 7. Our value is now 6. Just like before with any move function on a data register, if you push all of them, it just goes with the highest value. So right there, it's just, it's actually lagging behind a little bit. No, I'm sorry. I pushed 4 by accident. So now it's at the highest value. So, I took that off and it's now down to 4. I took that off, it's down to 2. And so the last value that I had on was 2, and there's our move function. So hopefully that makes sense. You do want it to be momentary, and the last one you had on will be the value. So right now our off delay time value 2 variable is set at 2 seconds. So I turn on input 4, and you'll notice the output did turn on, but our timer did not turn on yet until we lose that input, and then our timer starts and our output will turn off. Here it is. Okay, I pressed it and left it on. See, now our output turned off. So let me do that again. So I turn our output on, and then we lose the input. The countdown time starts and it goes off. So just remember, that's how an off delay timer works. You have an impulse, and then when that impulse stops, the countdown starts to turn off whatever you turned on with the impulse. And like I say, we just have a local variable here that was set to look for a time value. And then we have our move functions and our inputs that move those functions over. Pretty much just like the delta stuff that we talked about before, right? Now, let's see here. Let's go to our third thing. Our third thing is an up counter. Right here, this is reset, right? Our counter has to have a reset. So, first of all, you'll notice 27 is way over to the right on our PLC. That's our reset. I just set it apart from everything else, so it's easier for me to see. So we have a reset. Now, our preset value is 2. The reason why we started with 2 is because you remember those outputs were on, so I just preset a value to turn them off. And that was one of the ones, because when it was 0, the output was on, right? So right now I had pressed 9, and if you have any doubt, rewind the video and you can see I was saying, I'm going to press 9 and 16. But anyway, if you don't, you're not worried about it, don't worry about it. I pressed 9, and that's why I have 2. But if I press and input 10 right here, I will have a count value that I am looking for. For some reason it's not. Oh, it's not in run. For some reason I took it out of run. There we go. So now let's try this again. I'm going to press input 10. And see, the count value moved up to 4. I press input 11. And it moves the count value to 6. So like I say, this is an up counter. That's a local variable. These are move functions. I just press the input just like all the other moves by now. Hopefully you've seen so many moves, you're getting sick of them, but we're just moving values into it, right? So this is just, like I say, we're just going over this to really show you what the Allen Bradley looks like. It looks a little bit different, but it's similar enough that hopefully it makes sense to you. So anyway, so we hit that counter, and you know as well as I do, we have our input here that actually does the count. That is input 8 right over here. So right now I've set my count value to 6. So then I press input 8 6 times, and we will notice an output right there that just turned on. And then I reset it and that output turns off. So I'll put input 9, we'll set our count value for 2. And then rather than pressing it 6 times, I just have to press input 8 2 times. 1, 2. And, oh, you know what? I left my reset on. Oops. So that's why it wasn't doing anything. That's why you want your reset to be a push button too, so you don't toggle it on and leave it on and things get jacked up. So now my move value is still 2, and I'm going to try this again. 1, 2, and our counter just turned our output on. So let's see here. We're almost done. Okay, so right here we have an on delay timer, but we set 10 seconds for our preset time. We didn't do a local variable. We did our local variable for our elapsed time over here. And I just called it elapsed time 1 for elapsed time. The reason why I did that is because I have these comparators and we're comparing 2 values. The first value on these comparators is the elapsed time. So we're comparing the elapsed time to a greater than and a less than value. See, if you can't see these symbols, it's greater than and less than. But we got 0 and 0, so we need to use a data register. So input 13, we'll move 4 and 6 into it. And then input 14, we'll move 1 and 9 into those 2 values. 1 and 9. So the lesser number, if I push 13, will be 4, and the greater number will be 6. If I push input 14, the lesser number will be 1, and the greater number will be 9. And when it's in between, when it's greater than the lesser number and less than the greater number, we have our output on. So basically what that means is you'll see functionally our output will stay on longer when I push the input 14 move. It'll stay on for 8 seconds, and our output here will stay on for about 2 seconds. So hopefully that makes sense. I know I'm saying a lot of inputs and outputs, and can kind of be confusing. Heck, it can be confusing for me sometimes too with all this, trying to talk and do it at the same time. But let's see what we can do. So right now we'll basically pay attention to our comparators, because our timer, you can understand it's still set for 10, so it's not going to change, right? What's really changing is these comparators, these time value 3 and 4. So digital input 13, I push it, and all of a sudden I have 4 seconds and 6 seconds. So whenever I press input 12, that'll start the timer. And when we are in between 4 and 6 seconds, when this, and you'll see it by these elapsed times here. When these elapsed times here, remember, they're the same exact thing as the elapsed time in the timer. When they hit 4 and 6, we will have an output down here turned on. I believe it's output 3. It's output 3. It's right there. So let's see here. Let's push 12. And you see the elapsed time going. and you see the output turned on, and then it just turned off. Just turned on shortly, and the 10 seconds goes, and then it stops because it was a 10-second timer, right? And then I turn it off to reset the darn thing. Our elapsed time is back to 0. And if we press input 14 moved 1 and 9 over into these two values. So now when the elapsed time is greater than 1 and less than 9, we will have an output. So I'm going to push input 12. You see the elapsed time going. We have an output because we're in between 1 and 9. And you notice this output stayed on longer than before. It stayed on for 8 seconds versus 2. So that's kind of how you can put a local variable into comparators, and then you can use the move function just like for any other local variable. We just basically put in the comparator and use the move function. We just did for each input, we did 2 different move functions for each side of the greater than and less than. Let's see here. So then we, I think, have one more. Okay, so here's an up counter, and basically I have math functions here. So this up counter, I've got a count value. This is the local variable here. It says count value 2. The value is 1. Why is the value 1 and not 0? Because I've already done the move function to turn off, because originally we had the outputs on, and because they were at a value of 0, and so every counter with a value of 0 is on. So I've already done the move function here. So it's 1, but you'll notice here, input 17 adds 1, input 18 subtracts 1, okay? I'll actually take this off. And so input, let's get back down there. Every time I push this, it goes back up. Let's see here. So right here, so input 16 moves 1 into that counter. Input 17 adds 1. If you can't see that symbol, that is a plus symbol. It doesn't say ADD like the delta or the SUB like delta. It just gives the signals, right? So there's a plus signal, a minus signal, multiplication signal, anyway, there's the multiplication symbol. So we're going to multiply by 2, divide by 2. So each of these inputs, 17, 18, 19, 20, add 1, subtract 1, multiply 2, divide 2 is what it does. And you will notice when I push them, just kind of watch right here with this point value, right? If I press 17, what happens to it? We added 1. If I press 17 again, we added another one. We're up to 3. I press 17 again, we're up to 4. We're just adding them, right? If I press 18, which is right down here, we subtract 1. And so I pressed 18 once, we're down to 3. I press 18 again, we're down to 2. And if you'll remember, the 19 will multiply, right? So 2 times 2 is 4. We got 4. Times 2 again, we got 8. Times 2 again, we got 16. So we're just using these inputs, push buttons, whatever, to add, subtract, multiply. Let's do 20. We divide by 2 there, so we're back down to 8. Divide by 2 again, we're back down to 4. So that's kind of, you'd put the push buttons like what you saw in my physical demonstration to each of these inputs, and you just, push a push button to add, subtract, multiply, divide, and that's how you do it. So this counter is right now set to 4, and of course input 15 will be like the photo sensor or whatever that counts it. So then we do 1, 2, 3, 4, and you see at 4 the output turned on, right? And then let's just say I divide that by 2 again by pushing input 20. I'm back down to 2. Of course, the output's on because I'm at 4 and I'm above 2. So what we'll want to do is reset that. And now we don't have an output on Y because our count value is at 2, and we reset it to 0. So input 15 does the counting. 1, 2, and the reason why I didn't do anything is I left my reset on. That's why you want the reset to be on a momentary push button, not a toggle. So now I turn my reset off, and I push 1, 2, and we have an output that's on. And so that's just kind of how local variables, basically they're the same as data registers in Delta. We just use local variables to assign values to all kinds of things that need numerical values. I just showed you in the timers, counters, and comparators, but there's all kinds of things that use that. But that just kind of gives you an idea of how these local variables work and how different numbers can be assigned and how functions can change based on how an operator chooses values that they are looking for. Okay, so hopefully that was clear. If it was clear as mud, you can look at it again. You can always ask me questions, but hopefully that stuff was pretty clear, and we'll just kind of see you in the next video. Thank you. Bye.